Hey, welcome! Today, we're going to put on our detective hats and become cosmic investigators because we're tackling one of the biggest, strangest mysteries in the entire universe: dark matter. So let's just start with a really mind-bending question. What if everything you see, the stars, the galaxies, all of it, is just the tip of the iceberg? Because when we look out into the cosmos, we are not seeing the whole picture, not by a long shot. In fact, if you look at the data from space telescopes like Planck, it's pretty shocking. Everything we know, all the atoms that make up you, me, the planets, the stars, that's less than 5% of the universe. So what in the world is the rest? Well, as you can see, a huge chunk of that pie, about 27%, is our prime suspect. All right, so to crack this case, we're gonna follow the evidence, just like any good detective. First, we'll get a profile on our suspect. Then, we'll look at the evidence written in the stars, and even listen for echoes from the Big Bang. After that, we'll join the global hunt, consider a surprising plot twist, and finally, we'll have to redefine what it even means to see something. Okay, let's get right into it. Our suspect is called dark matter. And the funny thing is, it's actually easier to describe it by what it is not. So here's what makes dark matter so wild. It doesn't care about light at all. It doesn't shine, it doesn't cast a shadow, it's completely invisible. But, and this is the whole key, it has mass. And because it has mass, it has gravity. That gravitational pull is the one and only clue it leaves behind at the cosmic crime scene. It's the only way we know it's there. And our first big break in the case comes from just watching galaxies, because when you look closely, you realize they are moving all wrong. Now, this isn't some newfangled idea. Way back in 1933, an astronomer named Fritz Zwicky was looking at a cluster of galaxies and realized, wait a minute, these are moving so fast they should be flying apart. He figured there must be some dunkel materia, German for dark matter, holding them together. But it was the incredible work of Vera Rubin in the 1970s that really blew the case wide open. What Rubin found was just staggering. The stars on the very edge of spiral galaxies were moving just as fast as the stars near the center. Think about that. It's like the outer horses on a carousel spinning as fast as the inner ones. Physics says they should have been thrown off into deep space long ago. The only way they could stay in orbit is if the entire galaxy was embedded in a massive invisible halo of something, providing the extra gravity to hold on. Okay, let's move on to our next piece of evidence. And for this one, we have to travel all the way back in time to the very beginning of the universe itself. What you're looking at here is a map of the cosmic microwave background. You can think of it as the universe's baby picture, the leftover heat from the Big Bang. Those little colored spots are tiny temperature differences that were the seeds for all the galaxies we see today. But here's the thing. For those tiny seeds to grow into the gigantic cosmic structures we see, you need a lot of extra gravity. And it had to come from matter that didn't get pushed around by light and heat like normal matter did. You needed dark matter to act as an invisible scaffold. So with all this evidence piling up, you can bet that scientists all over the world are desperately trying to find this stuff. Which leads to the big question: how on earth do you catch something you can't even see? Well, it turns out they're attacking the problem from 3 different directions at once. First, they're looking for it indirectly, pointing telescopes at the sky, hoping to see a flash of gamma rays that could be a telltale sign of 2 dark matter particles colliding. Second, they're going for direct detection, building these incredibly sensitive experiments deep underground, shielded from all other radiation, just waiting for a single dark matter particle to wander through and bump into one of their atoms. And finally, they're trying to make it themselves, smashing particles together at insane speeds at places like the Large Hadron Collider to see if they can create dark matter right here on Earth. But every good detective story has a twist, right? And we have to ask, what if our prime suspect is actually innocent? What if it's not the evidence that's wrong, but the laws of physics themselves? This brings us to a fascinating alternative idea called MOND, which stands for Modified Newtonian Dynamics. This theory says, hey, maybe there isn't any missing matter. Maybe our understanding of gravity is just incomplete. The idea is that over really, really vast distances, gravity just behaves differently than we expect. And what's so compelling is that this idea can explain those weirdly fast-spinning galaxies perfectly without needing to invent a single new particle. And we have to take this seriously because this kind of thing has happened before in science. For decades, astronomers were puzzled by a strange wobble in Mercury's orbit. They even invented a whole new planet named Vulcan to explain it. But there was no Vulcan. The real answer was that Newton's theory of gravity was incomplete, and we needed Albert Einstein to completely rewrite the rules. It's a huge reminder that sometimes you have to question your most basic assumption. So all of this brings us to our final, and maybe the most important question in this whole investigation. What would it actually mean to prove that dark matter is real? I mean, it's the question on everybody's mind, isn't it? Are we ever going to get a photograph of this stuff? Well, the answer really forces us to think like a scientist. Seeing dark matter probably won't be like taking a picture with a camera. Instead, seeing it will be detecting that one unmistakable smoking gun signal. It'll be a tiny, specific blip of energy in one of those underground detectors, or a particle that pops into existence at CERN and then vanishes in a way that can only be explained by dark matter. That is what seeing it looks like in this case. Because you have to remember, the case for dark matter is already incredibly strong, built on so many different lines of evidence. We've talked about the galaxy rotation and the CMB, but it also perfectly explains how galaxies clump together in a giant cosmic web, and how light from distant objects gets bent by gravity from stuff we can't see. And then there's the bullet cluster, a collision of two galaxy clusters where the normal matter and the source of the gravity are literally pulled apart. All of these separate clues point to the same culprit. Getting that direct detection would just be the final, undeniable piece of the puzzle, the thing that connects a lab here on Earth to the mystery of the entire cosmos. And maybe that's the real takeaway here. This whole search for dark matter isn't just about finding some exotic new particle. It's a really profound reminder that the world we see with our eyes, the world we evolved to navigate, is just a tiny, tiny fraction of a reality that is so much larger and stranger and more magnificent than we can possibly imagine.